Here is a shop-made sheet metal brake mounted on a Black & Decker Workmate. Capable of up to 16 gauge, capable of extremely long lengths even though it's only 3 feet wide. I'll show you how I made it. Here it is, basically unmodified. I did put a brace in the legs, but I'm going to start by marking center, which is the rear draw. It's going to become my reference for everything. Here's the lower jaw of the brake, 1/4 inch wall, angle iron. I'll mark the center of that. Now there's 2 holes on these things that just happen to be 16 inches apart. So I'm going to drill a 3rd hole right in the center, right between these 2. And those are going to become critical for how this type of brake works. Looks to be 1 3/8 inches. So 1 3/8 inches. Double check that. Yep. Right there. Step 1, mark the center. Double check it. Looks good. The hinge screws on with number 10 screws. So to make sure that I have clearance between the hinge screws and the movable jaw of the Workmate, I'm going to space the lower jaw of the brake out 1/2 inch. So I have room to run through screws through here. So I'm going to do that now. Got it marked. Goes just like that. So I'm going to pop a hole through here and screw this down. Okay, here's the line. That's the back of my lower jaw, and it is 1 1/8 inches from my locator hole. So now I'm gonna pop a hole in my lower jaw at 1 1/8 inches, right about there. line it on the marks. There it is. I was mounting the hinge to the lower jaw, so I clamped a couple of brackets on here just temporarily. And the hinge needs to sit so the top of the barrel is flush with the top of the lower jaw. So when you stick a piece of sheet metal through, it lays flat. So I'm going to mark this hinge, center it, and then screw it in 2 places using some number 10 machine screws. Here's the lower jaw clamped up in the Workmate itself, centered on the mark. And that's how it's going to work. So I'm going to pick 2 holes back here, center mark them, and drill them out. I'm going to use my Starrett automatic hinge center punch. .3/16 bit for a number 10 through hole. Here she is bolted back down to the Workmate. Hinge is temporarily screwed on. Hinge is looking good. Laying nice and flat. Now let's attach the leaf, which is the part that comes down here that actually folds the sheet metal. Here's the leaf. Let's start by marking center. 36.5. Well, they cut this one a bit long for me. That's quite all right. Okay, I have the leaf temporarily clamped on with a couple of vice grips. And it has the same requirement as the lower jaw. It can't overlap the steel as it comes on, so the top of the leaf has to be even with the front edge of the lower jaw. That's just about right. That one's out a little bit, so take the old plumb persuader here and just tap it in line. Perfect. Okay, she's centered. Aligned. Let's mark the holes. There's the lower jaw connected to the leaf, hinging away, and actually it's already working. You can already use this. So what do I mean you can already use it? Well, let's do a demonstration. Here's a piece of simulated sheet metal, aka cardboard. Here's a simulated upper jaw, aka a piece of scrap. I just hold that down. We pick up the leaf. There you go. There you go. Already working. Making sure she's dead straight now. Parallel to the movable jaw here. And she is. Okay, so I'm gonna go mark my drill holes. These two holes on the movable jaw. I'm gonna drill them through on the lower jaw of the brake. So I'll go underneath and do that. There's my marks. Now if I did this right, those are about 16 inches apart on center. Yep. Okay, so I'm gonna go ahead and center them on this, 8 and 8. Use a steel rule for that. Okay, 8 and 8. Double check that. 8 and 8. Okay, looks like we're good. Now those are an inch and an eighth back from the edge to match this. Set my little stair square at inch and an eighth. There. And there. For this to work the way I want it to work, I need a hole every 8 inches. So that there's going to be 2 more holes, 1 at each end, 8 inches from this, 16 inches from this. That gives me a module or a consistent distance that I can use to space my bends, or my sheet metal to make bends. So I'm going to mark out 2 more 8-inch spaces. By 1 inch and an eighth. I'll punch and drill those 2, 1 on each end. Now if I did this right, these holes will line up with these holes. And they do. Re-bolted on here. Okay. Realign it one more time. And then snug these down so I can flip it over and work out the attachments. Welcome to the floor. So here's how the mounting is going to work. So I've got this 2 of these old brackets, I think are from a desk or something. I garbage picked them. So I'm going to use that as a bolting plate for the lower jaw. And then I got 2 of these from the hardware store on sale because it was my birthday. That's going to go there. And then I'm going to take a piece of angle iron and that's going to go there. So I'm going to cut this off. That looks like a job for the skill saw. I'm going to weld that to that and the angle iron to that. So this angle iron will pick up the cross member and transfer all the load, or a lot of the load, from the brake all the way to the back leg. I think I got this figured out. So this is the future sheet metal brake Workmate inverted on top of the industrial strength Workmate. So I cleaned off the powder coating over here, and this piece of angle is going to go there, and I'm going to weld it to that. So I'll tack that up. And on this side, little bracket there, buried in clamps, but I took the powder coat off of this side member, and I'll weld this little bracket to the side member, and I'll weld both the angle iron and the little side bracket to this intermediate plate right here, which is a piece of the desk bracket that I cut off that looks like that. That's for the other side. And then the lower jaw of the brake will bolt on to that intermediate plate bracket. So kind of a lot of metal and clamps in here. You can see a little bit better over here. You can see that intermediate bracket right there, intermediate plate. So that's going to get welded to the angle iron. Okay, I'm gonna leave these clamps on until I get the thing flipped over. So I make sure everything's aligned and righteous and working from above. And then I'll weld these on to the cross member. Now I'm gonna do the other side over here. Same process. I'll remove this, I'll remove the powder coat. I'll lay the angle iron in here, fix up the bracket up here, get it tacked in place. Okay, all tacked. I'm gonna leave these clamps here too. Flip her over and line it up from the top. And Boy, that powder coat stinks. All right, there it is in one piece. Tacked on, brackets are on. Just got to bolt through the lower jaw into these brackets and then mount the upper jaw. It's face down now. I'm gonna drill mounting holes through the intermediate plate into the lower jaw. Get those marked and drilled. I'm gonna go 7/8 from the bottom. And I'll go over 1 3/4, call it. Right there. I've removed the outboard bolt. There's the center bolt there. Remove the outboard bolt, and I'm going to drill straight down all the way through into this angle iron, and then a long bolt will clamp all that together. Time to mount the upper jaw. So here it is. It needs to be drilled in 5 locations. I drilled one there, but I messed up. It's in the wrong place. So there'll be another hole. I'll explain why later. Okay, he's transferring the center lines. Just using the square edge of this piece of sheet metal to scribe the center lines from the lower jaw to the upper jaw. Extreme close-up of the end, the left-hand end of the upper jaw and of the lower jaw. This is the leftmost hole. And I just put a piece of tape on here so it's easy to see. So as we fold the sheet metal that we're going to fold, there's a little bit of overbend. I'm actually going to grind this so there'll be even more overbend than this. So this is kind of a minimum case. If I do that, so this is no sheet metal in it at all. This is just an empty break. So if I look at that, and then I mark the center of the lower hole onto the piece of tape, I get this. But I need to account for the thickness of my sheet metal in here. So this is a piece of shim stock. If I'm bending this, you can see it moved it just a wee bit. This is a piece of 16 gauge. If I bend this, you can see it moved it back even more. Now that's as thick as I'm likely to bend on this thing, but if I ever get stupid and crazy, this is 12 gauge, which I don't think I'll be bending on this. Well, let's just say I try it. It moves back even more. So now the whole center line is here. So these holes on the upper jaw are going to need to be elongated. They're going to need to be oval or just larger in diameter so that the upper jaw can float back and forth as different thicknesses of sheet metal are bent. I'll measure that up and see what makes more sense, elongating holes or just drilling them bigger. Hope there's not too much glare, but there's 2 3/8 holes, one drilled on the frontmost position and one drilled on the rearmost position. And that would require a 1/2 inch diameter hole to cover the range. But since this is likely to go backwards more as I increase the angle of travel, when I grind this off, I'm going to get more travel and it's going to push the upper jaw further back. I'm going to go with this, which is a 1/2 inch hole on the center of the frontmost hole. So when the leaf is up and there's a piece of thick sheet metal in it, this is as far back as you're going to get. And this hole will allow the rear jaw to be moved forward again when you're bending thin sheet metal, just by loosening the bolt and tweaking it forward. So 1/2 inch holes aligned on centers with the 5 holes in the lower jaw. That's the next step. Looks like 2 1/8. Here's my scribe line right here. I don't know if you can see that. That's where my center is going to be, right there. Let's grab the other 4. Upper jaw is mounted with the enlarged holes, so now you can see the float that you can have based on sheet thickness. So when you bend sheet metal of X or Y thickness, you can move the jaw back and lock it in place. But to give it some memory, I'm going to attach one of these brackets, another one of these brackets here, and a bolt so that it can create a stop so that you can get back to your position every time you change your sheet out or change your bend. Okay, here's the idea. So, little stop bracket, screw, threaded plate. I can move the jaw back and forth. I can change the adjustment on the screw back and forth And then when I fold, I can adjust the gullet left for the sheet metal to flow in. So, very simple. I'm going to weld these little weld nuts onto the brackets. This is what I would call our minimum viable product. Got the stops on. I didn't have the camera running, but I welded on 2 pipe couplings and using 12-inch pipe nipples for handles. It's all tacked together. I got some grinding to do, but this is about as far as I'm going to go with this, because I'll probably add other features once I start using it. But from here, I'm just going to do the grinding, clean off all the scale, finish it, weld up the Workmate, do all the final welding on the brake itself, get a coat of paint on it. But it's usable right now, so I don't want to do anything heavy because everything's tack welded. I don't want to break any welds, so I just got a piece of 16 gauge clamped up in it, just very small piece. And here you go. Voila. Just like that. Just to try it again, just for the hell of it. Overbent it a little bit. Time to do some grinding. In order to increase the bend angle, I'm now going to grind that edge, and that edge. And just to make sure I don't get any argument, this is what I'm going to use. My big old 167 Milwaukee 7-inch angle grinder. I love this thing. Using the Starrett angle finder here, protractor. Looks like I'm getting about 16 degrees of angle. With my random orbital sander, it's just 60 grit aluminum oxide. The thing is though, not only to make the edges nice and smooth, but this edge right here, this is the leaf. whatever is on there, whatever sanding marks, imprints, indents, grooves, whatever, that's going to show up in your finished sheet metal. So you want to make that nice and smooth, especially if you're working with aluminum. It'll just leave its fingerprint right into your metal. And then you'll just be working it out of every piece that you bend for as long as you use this thing. So take your time and sand it out. This is the upper jaw. Same admonition. On the edge towards the leaf, sand it out, because this too will leave its fingerprint right on your sheet metal. Here we are on the test fit of the ground hinge, ground lower jaw, and ground leaf. Let's see how much angle we got now. Oh, quite a bit more. Let's see, kind of eyeballing that. Wow, almost 30 degrees, 29 degrees call it. So we went from 16 to 29 degrees of overbend here. I'm happy with that. That'll give me plenty to overcome spring back even on heavy metal. Here it is in its final, its last test fit up. Everything works. All the bolts go through all the holes, the hinges fit. I'm getting my overbend. I could do more, but I'm going to stop right here and use it once or twice before I add too many more features. I could already see a couple little things I might want to add, but I'm going to stop right here because I don't want to overdo it or do something that I have to undo later. So I'm going to clean up, paint, and assemble. Here's the base, all painted up and ground up. All the edges are sanded and everything's nice and smooth. Let's start the assembly. just like a regular Workmate. Here she is. I went ahead and put in all the piano hinge screws. How this works is kind of like an aluminum trim brake works, if you ever used one of those. It has a continuous hinge. So the upper jaw and the lower jaw and the leaf support each other all the time. So you don't have pin hinges at the end, so your members can be smaller for bending thick metal. And then this one, we have these holes. So if we want to bend something narrow, we can put a bolt in here, put a bolt in here, and then the upper jaw and the lower jaw support each other. and you get a nice clean bend without a lot of effort. Or if you're bending a really long piece, you can do the same thing. You can drill a hole in your sheet metal, put this bolt in, or all 5 of them, make your bend, but then you're gonna have to patch up holes in your sheet metal after you make your fold, which is not a big deal if you can weld or solder. It's easy. It'll probably never look this good again. The life of a sheet metal brake is a rough life. So there it is. Okay, let's see it in action. So this is a piece of 19 gauge rusty old sheet metal that I found actually on the railroad tracks near my house. So let's put it in here and put a fold in. This is 19 gauge, 27 inches wide. Okay, unbolted the upper jaw. Get this thing out of here. And this thing's covered with some kind of crappy paint, but you can see under there's a nice bend. Looks better on the inside. So success. So I'm going to call this one good right here, and it's on to the next project. I will see you there and then.